Mathematics is not about numbers, equations, computations, or algorithms. It is about understanding by William Folterston. To my fellow mathesians, to our respective instructor, and to all the viewers who are watching now, good day. I am Josajane Sabalia from Tribe 1, Julia Set of Section J. In this moment, Julia Set is here to tackle the given topic to our tribe, including variables, the language of set, and the language of function and relation. And now, allow us to start the discussion, and we are sure that you will learn from it.
In math, a variable and alphabet or terms represent an unknown number or unknown value or unknown quantity. The variable are especially used in the case of algebraic expression or algebra. For example, x plus 9 equals 4 is a linear equation where x is a variable where 9 and 4 are constant. The variable is quantity that can be changed or made. Usually, in algebra, we express an unknown number using the terms x and y. But this is not a particular. We can use any alphabet.
These variables can be any alphabets from A to Z. Most commonly, A, B, C, X, Y, and Z are used as variables in equation. Making arithmetical calculation with variables as to they were expressed numbers permits one to take care of scope of issues in a solitary relations. Ordinary illustration is a quadratic recipe, which allows one to explain each quadratic condition by just substituting the numerical estimation of the coefficients of the offered condition to the variables that speak to them. The idea of a variable is significant in math. Regularly, a function y equal f includes two variables y and z. Speaking individual, the quality and the contention of the function. The expression variables originate from the way that when the argument additionally called the variables of the capacity shifts, then the quality change accordingly.
The equation in mathematics are formed of different parts. They are variable, coefficient, constant, operator, and terms. For example, the equation is 3x plus 9 equals 21. The 3 is the coefficient. The x is scaled variable. The 9 and 21 are scaled constant. And the plus sign is the operator. An operator is an arithmetic symbol that is used to perform various operations. These operators are addition, subtraction, multiplication, and division. Term is a single expression of an equation. It can be a number or variable, or number multiplied by variable. In the above example, x and y are scaled variables.
Constant in math. The constant in math are the values which cannot be changed or which are fixed. It is a contradiction to the variable. In algebraic expression, the constant are terms which define themselves. For example, if 9x plus 2 is equals to 15, 15 is an equation. Then x is the variable, which can have different values, and 9 is the coefficient of x. But the number 2 and 15 are the constant here. statistic, the variables are used in terms of real-life scenarios. It is also said to be an attribute here. They are used to representing people, places, things, and etc. For example, the color of the hair of a person is a variable, since the hair color could vary from person to person. Like for some it is blonde, and for some it is black, or other colors.
Types of variable in math. The variables can be classified into two categories, namely dependent variable and independent variable. Let's discuss the two types of variable in details. Dependent variables. The dependent variable is characterized as the variable whose quality depends on the estimation of another variables in its condition. That is, the estimation of the word variable is dependably said to be reliant on the free variable of math condition. For instance, consider the condition y equals 4x plus 3. In this condition, the estimation of the value y changes as per the adjustment in the estimation of x. In this manner, the variable y is said to be a real variable. Portion of the cases that include subordinated variables is talked about in point of interest as Binet with their answers. Independent variables. In an algebraic equation, an independent variable describes a variable whose values are independent of changes. If x and y are two variables in an algebraic equation and every value of x is linked with any other value of y, then y value is said to be a function of x value known as an independent variable, and y value is known as a dependent variable. Example, in the expression y equals x squared and x is an independent variable. Thus, we can summarize the variables mathematically as given below. In mathematics, we can define variables with the help of a function. In simple words, a function is a rule for taking a number or set of numbers as input and producing an output, which may also be a number or a set of number.
A mathematical language and symbol, the language of set. So what is set? A set is well-defined collection of distinct objects. It's usually represented by capital letters. So when we use language of set, we must use the capital letter. The object of a set are separated by commas. In using set, we use also the commas. The objects that belong in a set are the elements or members of the set. Ang tawag dun sa makikita natin sa set ay members or elements. It can be represented by listing its elements between braces. We use braces when we use the language of set. A set is said to be well defined if the elements in the set are specifically listed. When we say well defined, this is the example. The set of vowels, the braces A, E, E, U, U, and then the set of plain figures, the set of the table of elements. Notation. If S is set the notation, how we read this? X is an element of S. X is not the element of S. May slash lang siya sa etong isa. Kaya, ang basa dito ay X is not the element of S. Eto, X is element of S. Okay. When we say well-defined, kagaya nitong 1, 2, 3 to 100. Nag-start siya and then nag-end siya sa 100. Yun ang tinatawag na well-defined. That is specifically listed. 1, 2, 3. Ito naman, 1, 2, 3, well not defined. Because walang last na element na nakasunod sa 3. When we say ellipsis, ginagamit kung maraming elements.
Using the set roster notation. A set may be specified using the set roster notation by writing all elements between braces. Example, how many elements are in the set 1 and 1? The set 1 and 1 has 2 elements. 1 and the set whose only element is 1. For each non-negative integer n, let the use of n is equals to n and negative n. Find the use of 1, the use of 2, and the use of 0. The use of 1 is equals to 1 and negative 1. The use of 2 is equals to 2 and negative 2. The use of 0 is equals to 0 and negative 0. Equals 0 and 0 is equals to 0. Cartesian sets of numbers. Some important sets are the following. N represent the set of natural numbers. W represent the set of the whole numbers. Z represent the set of integers. Q represent the set of rational numbers or terminating or repeating numbers decimals. Q prime represent the set of irrational numbers or non-terminating, non-repeating decimals. R represent the set of real numbers. And C represent the set of complex numbers.
Set builder notation. Let S denote and let P of X be a property that elements of S not satisfied. We define a new set to be a set of elements X in such that P of X is true. And now we denote this set as follows. Using the set builder notation, given that R set of all real numbers, Z the set of all integers, and the set of all positive integers.
This is the set of all element x in real numbers such as x is greater than negative 2 but less than 5. So, ibig sabihin yung element natin ay mas mataas sa negative 2 pero mababa sa 5. If the open interval of real numbers is strictly between negative 2 and 5, it is pictured as follows. So, between 2 kasi nag-meet sila sa gitna. The set of all element x in the set of integers such that x is greater than negative 2 but less than positive 5. Is the set of all integers strictly between negative 2 and 5. It is equal to the set negative 1, 0, 1, 2, 3, and 4. The set of all element x and positive of integers such that x is greater than negative 2 but less than 5. So, ito naman po, kukunin natin yung elements na mas mataas sa negative 2 na mas mababa sa 5. Pero ang condition niya, positive integers. So, therefore, ang elements na lang natin ay 1, 2, 3, and 4. Kung babalikan natin yung kanina, meron siyang negative 1 and 0. But this time, hinihingi niya lang is positive of integers. So, mawawala ngayon sa negative 1 and 0. So, ang may iwan na lang is 1, 2, 3, and 4.
But before we proceed, let us talk about the definition regarding sets. A set is finite if the numbers of elements are countable. For example, in set A, we have even numbers that is less than 10. We have 2, 4, 6, and 8. For set B, we have the days in a week. We have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. A set is infinite if the number of elements cannot be counted. For examples, in set A, we have even numbers greater than 20. For set B, odd numbers. And for set C, stars in the sky. Equal and equivalent sets. Equal sets are set with exactly the same elements and cardinality. When we say cardinality, it is the measure of set size, meaning the number of elements. Examples. For set A, we have C, A, R, and E. For set B, we have R, A, C, and E. Equivalent sets are the sets with the same number of elements cardinality. For example, in set A, we have A, E, O, U. For set B, we have 1, 2, 3, 4, and 5. Joint and disjoint sets. Joint sets are set with common elements or intersection. Example, for set A, we have Z, A, R, and E. For set B, we have B, E, A, R, and S. Disjoint sets are set with no common elements. For example, for set A, we have A, B, and C. For set B, we have also E, F, and G.
Relation and function are the most important topics in algebra. Relation and function. These are two different words having different meanings mathematically. You might get confused about their difference. Before we go deeper, let's understand the difference between both with a simple example. An ordered pair is represented as input and output. The relation shows the relationship between input and output, whereas a function is a relation which derives one output for each given input. Note: all functions are relations, but not all relations are functions.
What is function? A function is a relation which describes that there should be only one output for each input, or we can say that a special kind of relation is a set of ordered pairs which follow a root. A set of x values should be associated with only one x value is called functions. For example, domain range -1, -3, 1, 3, 3, and 9. Let us also look at the definition of the domain range of a function. Domain, it is collection of the first values of ordered pairs. Set of all input as follows. Range, it is collection of the set of values and the ordered pairs. Set of all values. Example, in the relation curly brackets -2 and 3. Curly brackets, close and open parenthesis, 4 and 5. Close and open parenthesis, 6 and -5. Close and open parenthesis, curly brackets, -2 and 3. The domain is curly brackets, -2, 4, and 6. And a range is curly brackets, -5, 3, and 5 curly brackets.
Term of relation, we can define the types of function as one-to-one, one-to-many, many-to-one, many-to-many. So, when we say relation is the set of ordered pairs, aside from the ordered pairs, a relation can be represented by number 1 is table of values, number 2 is mapping or arrow diagram, number 3 graphing, number 4 is rule. Example of set of ordered
Let name using our first table of values. X is 0, 1, 2, 3, 4, 5, 6. Y, 6, 5, 4, 3, 2, 1, 0. And this is the example of table of values.
A set of ordered pairs is a number used to locate a point on the coordinate plane, where the first coordinate represents the horizontal position in X and the second coordinate represents the vertical position, which is the Y. So, mapping our diagram, X coordinate and Y coordinate. Take notes, our abscissa ito ang unknown domain where the value of X and Y coordinate is arranged. So guys, let me give you or show you an example of ordered pairs. Example, 0, 6, 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, and 6 here.
Set of order pair is have 0 and 6, 1 and 5, 2 and 4, 3 and 3, 4 and 2, 5 and 1, and 6 and 0. This our origin, the coordinate is 0, 0. Copy from the right side, our vertical line is 1, 2, 3, 4, 5, 6, and sa awkward naman is 1, 2, 3, 4, 5, 6. Then sa lower part naman, we have a negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. Sa left side naman, we have negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. This our going to connect. Ito kasi F0 is X coordinate, and Y naman is Y coordinate. So, 0 and 6, 0 and 6, and 1 to 5, and 2 to 4, and 3 to 3, and 4, and 2, and 5 and 1, and 6 and 0. This now, kukonect lang natin sila. Hindi pansin. And this is now our order pair. Plotted order pair, our rectangular coordinate system. We lower the point with our graphs.
Group or set of order pairs have 0 and 6, 1 and 5, 2 and 4, 3 and 3, 4 and 2, 5 and 1, and 6 and 0. Going to add to sum theta and coordinates. So 0 plus 6 equals 6, 1 plus 1, 5 equals 6, 2 plus 4 equals 6, 3 plus 3 equals 6, 4 plus 2 equals 6, 5, 6 and 0 equals 6, and x plus y equals 6. And that is the example of rules.